Hi there, this is exercise AT for further mathematicians. It's finding the mean value of a function. And it says at the top, actually, the mean value is the average value of the function. So in other words, I'd think of this as the average height of the curve above the x-axis. Now, I don't know what, obviously these are two numbers, say -1 up to 4, something like this. And what would you see? It'd be tempting to always say, what's the end point, and just find the average of the two. But we've got to take account of the fact that the graph might not go up in a straight line. In fact, most graphs don't. And this one, you can see, curves down. And so the average must effectively, the average height of that curve must be a bit lower than otherwise it would have been. And so what we do is we effectively say, well, how wide is it from A to B? Say it's 4 apart, 5 apart, whatever. And we find the area of the curve, this area, the area underneath the curve, and we divide that area by this width. And that dividing the area by the width will give us the average height over this period. And we call it the mean value of the function. So bear that in mind. Write this down then. This is the formula we've just seen. And you might want to give some kind of wordy description of what it is. But as I said to you, we basically integrate and divide. That's the trick. So we've got a couple of examples for you. This one says you are given that f of x is x squared minus x. Now, I know I've drawn the graph for you. I don't think there was a graph drawn in the original question, but I've drawn it anyway. The way I draw this, obviously you could cheat a bit on the calculator. I'd factorise it, and x minus 1 is a factorised version. Therefore, well, for a start, we know it's a quadratic, so therefore it's a U shape. Where's it cross? 0 and 1. And you'll notice my graph does cross at 0 and 1. But we actually want to find the mean value between 3 and 4. So 1, 2, there's 3, and there's 4. So just looking at it, 3 looks as if it crosses at 6, and 4 looks as if it goes up to about 12. So the answer must be somewhere in between there. Now, that looks quite a straight line, so I'm guessing it's about 9, but I don't think it'd be exactly 9. So what we're going to do, we're going to, basically, if we want the mean value, I shall write mean value equals, and it's the 1 over b minus a. Well, how far apart are they? They're only 1 apart, so that's easy. 1 over 4 minus 3. Integral from 3 to 4 of x squared minus x dx. And if we integrate that, we get x cubed over 3 minus x squared over 2 between 3 and 4. Now obviously it's 1 over 4, so that's really just 1. So it's 1 times by that in this case, not always like that obviously. And if I put 4 in, I get 64 over 3. Notice I'm already ignoring the 1 because that's not going to make any difference. Minus, I put the 4 in, that's 16 over 2, which is 8. Minus, now I put the 3 in, 3 cubed is 27, over 3 is 9. And 3 squared is 9, over 2 is 9 over 2. I'm just going to work that in my calculator, this point is doing it any other way. 64 over 3. Minus the 8, minus in brackets 9 minus the 9 over 2, close brackets, nearly did that wrong, equals, I've got 53 over 6. Now how easy is that? Now obviously it all depends on how hard the integration they give you is. They get a complicated integration, it's a complicated question, but crikey, with this kind of function, this is quite easy and good. Well, I say all that, and at least I then did get the answer right. Here's another one. Oh look, this proves the point. This is now a complicated function. E to the 2x sine x. This strikes me, if I'm going to integrate this, this is going to be by parts. So if they want to make it hard, they can make it hard. But we've seen integration by parts, so we should now be able to do it. It's one of the reasons we taught you all those extra lessons. And anyone who hasn't done those extra lessons yet, you need to go back and do them. So what's it saying? It's between 0 and a quarter pi. And I think I've already shown on this graph what's going on. This is the line x is a quarter pi. It's just gone off the bottom of the screen. You can't see it. But presumably, between those 2 points, I want to know the average height of this curve. and it goes from 0, 0 up to, well, whatever that is up there. And well, I'm expecting the answer to be around here somewhere, about 1.5-ish, but who knows. Let's do this problem then. So the mean value equals, and by the way, the mean value could be written as y bar, I suppose. It's the average of the y's, if you like. Anyway, so it's 1 over b minus a. And what's 1 over b minus a? Well, it's 0 and 1/4 pi. So I think it's 1 over 1/4 pi minus 0 times by the integral from 0 to 1/4 pi of e to the 2x sine x dx. And obviously I can ignore that. And if I do 1 over 1/4, it's the same as 4. So this is like 4 over pi times by whatever this is. Now I'm going to have to do this as a u equals. Now you should remember the late rule when we did this, and the late rule basically said if you have a trigonometric and an exponential, which we have, this will be the higher up will be my u, and this will be my dv by dx. So u in this example is sine, and therefore du by dx is the differential of that, which is cos x. And then I have a v and a dv by dx. That's a v on this, and that's definitely a u. This one is the e to the 2x, and I integrate that and I get a half e to the 2x. Now you might recall what happens when you get these exponentials and trig functions together. You might not, but I'll go through the process. So you times these two together, I get a half of sine x e to the 2x minus the integral of these two times by each other, which is a half of e to the 2x cos x. And this is what I was saying about, you might recall, that you end up doing this twice. So remember, this is what we're trying to find. So I'm going to start off over here. So I'm going to get rid of that, and I'm going to save that up there in a bit. The integral of 1/4 pi to 0 of e to the 2x sine x, just to make it clear what it is we're doing. And I'm going to call this I. This is what we're trying to find, this thing here. And then I'll worry about the 4 pi thing, or 4 over pi thing at the end. So what are we doing? Well, I is equal to then, the first bit's fine. It's a half of sine x e to the 2x. Minus, now this is the bit that's not fine. We've got to use by parts again. So this time I say u equals cos x. As I say, du by dx, and you may recall that it goes sine cos minus sine minus cos. So I'm going to get minus sine x here. V equals, and dv by dx equals, my dv by dx is the e to the 2x again. So that's a half e to the 2x over here. So it's minus. Now I've already got a half. So it's a half of these two, which is a half cos x e to the 2x. And it's minus the integral of these two times by each other. And it's already got a minus, and it's already got a half. So I'm going to write plus a half integral of e to the 2x sine x. And the reason why I've made such a palaver about all that lot is because this lot is what we started with, and that was the trick. So we end up with saying that the integral, is a half sine x e to the 2x minus half of a half is a 1/4 cos x e to the 2x. Half times a half is a 1/4 minus a 1/4. And this thing is what we started with. So that's an I. So if I move that over, that's plus an I on top of the I already have got, that's actually 5/4 of I equals a half sine x e to the 2x minus a quarter cos x e to the 2x. And bear in mind, this actually has still not been, I've still got to put 0 and pi, a quarter pi into that. Right, so let's start putting these numbers in. I've got a quarter pi to go in, so make sure your calculator's in radians, and I'm going to type in a half times my sine of x. Now that's all I'm going to put in. Now of course x is quarter pi, so that goes in. And I've got to do that, I think, because otherwise I think I'm going to lose the accuracy of this. So when I put that in, I will get √2/4. But I still need to put it into the e to the 2x. So it becomes e, and 2 quarter pi is obviously a half pi. So √2/4 e to the half pi minus, and it's a quarter cos x. So I can do the same thing there. So I'm going to do a quarter times cos of a quarter pi again. So and I get √2/8. So in this time it's √2/8, and that's done the cos, but I still haven't done the e to the 2x on this, so I'll put the quarter pi into that. I get e to the half pi again. Minus what I get when I put 0 in. Now, the great thing is, if I put 0 into sine, I get 0. Sine of 0 is 0. So effectively I can ignore all of that. The only one I need to worry about is the 0, because 0 into cos goes 1. Whereas I say this one was 0. So it's a quarter times 1 minus a quarter there. And e to the 2x, e to the 0 effectively, will be 1. So that's what I get. So if I just tie that up, now I can take out the e to the half pi as a common factor. And all I've got to do is, if that's the equivalent of like a quarter, take away an eighth. So I think that should be a quarter of √2. So I'll just do it on the calculator, make sure I haven't made a silly mistake. So √2/4 minus the √2/8. And it's √2/8. I think that's what I said, but who knows. So that's √2/8. So that's dealt with that, and it's plus a quarter. Now that's not quite the answer, and the reason is because of that I trick I had, is equal to 5/4. So I think I've got to effectively times all of this, well, I've got to move the 4 over to the other side and divide everything by 5. So I think I'm just going on to the next slide. I'm going to then copy it out on the next slide and go with that. So there you are, I've copied it out. Now let's look at this. So as I say, I think the 4's got to go up and multiply, and the 5's got to go down and times. So it is over 8. So if I times by 4, that effectively goes up there. Oh, and don't forget I've got to do this thing here as well. And the 5 goes on the bottom of both of them, because I've got to divide both bits and times both bits. So the 4/8 I think cancels to 2, and then I've got 2 times 5 on the bottom. So I think it's √2/10 e to the half pi. And the 4's I think cancel, plus a fifth. And I think that is my integral. Now it's not quite the end of the show, because if you remember, if I go back, oh well, there's my answers come up here. Do you remember this thing? I have to now divide it because of this part of the rule. Divide it by 1/b minus a. And I said it was 1/4 pi. So I've got to times all of this then to get my mean value. It's 1/4 pi, which I said really was the same as 4/pi. So times by that little lot, √2/10 plus e to the half pi plus a fifth. And you know what? Last time I did that, I got the same answer. So I think I have actually got it right, but it's quite confusing that. And you're going to do exercise E, chapter 8E, and best of luck.